Cool. So I'm going to move on to control flow. So again, we have about 20 minutes, so I just want to make sure we have enough time to get through some stuff. Give me a thumbs up of how comfortable you feel about for loops, while loops, if statements. Give me a thumbs up if you're like, yes, totally got this. Thumbs down, like, I don't really know. Okay, see some thumbs down, see some sideways and stuff like this. Okay, so just quickly for the people who are sideways and stuff, if you're willing to share, is it for loops, is it while loops, or is it if statements that really trip you up, or is it all three? I know it's kind of, you go and unmute yourself.
The if statements and the while loops.
Okay, cool. All right. Anyone else would like to say which ones that trip them up a lot, or maybe a little more than normal? And thank you again for sharing, because I know it's kind of intimidating sometimes.
For me, it's just looping through dictionaries or like data frames that are like lists of dictionaries. Sometimes it gets tricky for me.
Yeah, looping for loops in Python are really interesting because it loops through what we call an iterable. So yeah, cool. All right, so let's go for it. So I'll take a little bit of time. If you're familiar with it, this will be a good review. Maybe you learn something new. All right, so if statements, basically an if in Python, this is the only part that's actually required. So we have if and a conditional statement. And note that we say a conditional statement, this has to be evaluated essentially as true or false. Note that Python is pretty forgiving. Like Python will kind of let you do stuff and just like say, all right, I assume you know what you're doing. So typically we say this conditional statement is either true or false. So we can kind of actually do this. It's a Boolean, right? So like, for example, say like 1 equals 2. Is this true or false? It's false. It's going to give us false, right? 1 does not equal 2. It's true, okay? 1 is less than 2. It's true, right? And if I did the opposite, greater than, let's say greater than or equal to, this would be false. So you can get the idea of this Boolean thing. So the idea here is that this conditional statement would have a Boolean. Technically, that is not 100% true because Python allows you to have truthiness, basically allows you to, and that's actual term, it's called truthiness. It basically allows other numbers, for example, is the number 10, is that true or false? Yeah, if you know it, it's true. Turns out it's basically everything that's not a 0. So if I do like f, oops. So it's a if, oh my gosh, if true. And then we have a execution. So we say if true, print hi. You can see it prints hi. If I do if 10, this will print hi, because it is true-y, you know, it is a true-y kind of thing. If I do if 0, this is actually evaluated as false. Fun stuff. If none, is anyone gonna guess what if none would give? Like just instinctively, would that say true or false, you think?
False.
Thumbs up. Yeah, so I hear false. Give me a thumbs up if you think true, thumbs down if you think false. Okay, cool. Yeah, you see you guys know what's up. You can see if I try to run this now, it does not. If I actually try, oops. If I just do not none, which would be the opposite of what none would be. So if none is in fact false, this should now run because it now is true. It gives true. So none is evaluated as these false things. You can also do weird stuff like an empty list, which you can see is also false. So Python tries to keep like what makes sense to be false, like empty stuff. But just kind of know is that in general, it's not the best practice just because you can get some weird cases where you're not sure if it's true or false ahead of time. But anyway, the main thing with if statements is that all you need is the if part. And then if that statement is true, it will execute the next part. So this little block, we call these like if blocks. Now for Python, this may be very different if you're a different Python programming. We actually have an else if. So an else if actually has a new condition under here. And this else and else if or elif, these things are optional. So you could just do the if part and then do nothing else. But the else if and else actually allows us to have more control. So if this condition is not true, or sorry, if this condition is true, it will do this stuff. If the condition is false, it will move on to the next part, which is elif, and say, oh, is this condition true? And then if this condition is true, it'll run this part and stop right there. If you have, if this condition is false and this condition is false, it'll move on to the next part, this else part. And this else basically catches everything. It's like if all of the things are completely false, it's just gonna default to here. You can, however, have this part completely removed, and it could just be if and elif. So what that kind of looks like would be like, let's say if false print 1. Oops. Sorry. My fingers are slippery today. If false. And I'm just doing shortcuts. You would never do it like actually like this, because why would you pass false in purposely? But I'm just kind of illustrating a point. You can have multiple elif like this. 3. And then I'm actually going to put this true here. So this, if I run this, it'll first check, hey, is this first condition, is it false? Or is it true? It's like, it's false, skip over it. And goes to the next one. Hey, is this condition true? Yeah, it's true. Go ahead and run this block right here. And then it'll stop right there. It won't check anymore. So if I go ahead and run this now, this will just print the number 2. Okay. If this was instead false, will this print anything? Yeah, I see some head shakes. No, because basically this is false. So move on to the next one. This is false. Move on to the next one. This is false. Move on to the next one. Hey, there isn't anything more. So it just stops. Okay. If we had else at the very bottom here, note that we don't put any condition. We actually will run this part. Basically says, oh, all of these are false. So go ahead and run this guy. Okay. If I had this as true here, it won't never reach to this part right here. So you'll see it says 2. Okay. Sound pretty good? Any questions on this if-else blocks? All right, cool. So now we have some special ternary operator. So you'll see this especially because data scientists love little short lines of code sometimes. And this is actually really useful for like list comprehensions and some other, functions like lambda functions and stuff like this. But it basically kind of shortens up what we have here. So I'm going to kind of walk through this. I have this flag here. So this is our condition. I should really just call this condition. Condition. I'm not a speller. I'm a data scientist. All right. So condition equals false. X is equal to 1 if condition, else 0. Python tries to make it nice and easy for us to read. So if you read this and you didn't know anything about Python, it looks like saying, oh, X should be equal to 1 if this is true. Otherwise, else, set X equal to 0. Make sense? Okay. So since condition is false, what should X be in this case? 1 or 0? See 0? Yeah. So I run this. See 0. Okay. If I change this condition to true, this will now print 1 or 0. 1, good. Good job, everyone. Okay. So really you can kind of think about this stuff on the side, like away from this. This basically says, all right, you can think of it as like X is equal to, and then it does this whole thing all together, and that's going to be whatever it gives. So for example, if I do like this plus like 2, this will either give us 3 or 2. You can see it gives us 3 here. This will give us 2. Okay, makes sense. Any questions? Go ahead, Nyla.
So,
Mhm.
so we would still use like what we went over in the beginning majority of the time instead of this way, or is this way the preferred way?
Yeah, usually I will say is that in general, in Python, and honestly data science, is that you don't want to write code that is more confusing than just if it can be written, like if it takes less room but is more confusing, write it the longer way. So
Okay.
we could have done something similar, like if I wanted to write this same exact things considering this condition, I could have done if condition, oops, X equals 1. So if this is true, set X equal to 1. Otherwise, X equals 0. And then I could have done like print X like this. So this is like, you can see it's a little bit longer here. So it does take some extra time. So that's why this tends to be done for things like list comprehensions, which we'll talk about in the future, and lambda functions, which tend to be these one-line kind of things. Like I just want to use this really quickly. And that's why you'll tend to see this. But it functions the same. You could go your whole life programming and never have to do this. But it helps in some situations. Okay.
Thank you.
No problem. Yeah. And good questions, by the way. You can see here, prints out, well, I changed this up. And then just note, I just kind of did the same thing here. In this case, y, z, and it says x equals y if y is less than z. Otherwise, just return z. So note this kind of is referring to some stuff, but it's the same example as this guy up here. It's saying, oh, if y is less than z, then we should just say x equals y. And then if it's not, then set x equal to z. So in this case, since y is less than z, 10 is less than 20, this should give us 10. If I had instead 100, this should give us 20. Okay. So you can kind of write these really quick things. But honestly, when you first look at this, this might be something that takes a while for you to like really comprehend. But you'll see it more and more. And I would say it's just try practicing this out, because then you start to get the feel for like how these things work. Okay. Cool. All right, so let's see, got about 9 minutes left. All right, go through for loops. So we have some for loops and while loops. So for loops in Python, if you did another programming language, for loops work a little differently than most other programming languages. Things like JavaScript, Java, C, all that stuff. So one thing to note is that basically Python with for loops will basically loop over an iterable. So an iterable, you can see this link right here, is basically something that can be like iterated on. Basically, you can get the next one, the next one, the next one, the next one, and so on. And this actually allows Python to make many different kind of like iterables. So a very common one is like you have a list of cities. So hopefully this top travel cities is still good. But basically it's like, okay, we're going to take for a city in top travel cities. And if you remember, if we look at top travel cities, we have this list of this guy. What's going to happen is going to say, okay, it's going to say, take the very first one, and then it's going to save that as city. And then we're going to do stuff in this for loop for that city. And basically it's going to iterate, right, over each city. So basically it's going to go, all right, for the city in top travel cities, which will be Solta first, it's going to do lower cities dot append city dot lower. So note that city will just be Solta, lowercase, and then it's going to add it to the list. And then it's like, okay, that's the end of that for loop right here. So you can see there's no more indent anymore, and it's going to loop all the way back up. So if I actually give a little space just to see this clear, it's now going to go back to the beginning and say, all right, the for loop's going to say, give me the next city. All right, and it says, oh, the next one is this guy. And it's like, all right, save this guy into city, and then it's going to execute this code underneath. And then when it reaches the bottom here, it's going to go to the next city, which will be this guy right here, and so on and so forth. Okay, so at the very end here, as we kind of go over and over and over again, basically this lower cities will keep appending to this list. And eventually, I go and just cut this up. So you can see here, it executed like a bunch of times, and then we can print lower cities, which should just be just this guy, but all lowercase. And there you go. Okay. Does this make sense to everyone? Yeah, go ahead. I see a question, Tyler.
Okay, so I just want to make sure. So the reasoning why we create a new list is so that way the loop is for that specific list that we're putting it towards. So that when we print it, that's what it's going to give us.
Right, yeah. So this is just kind of like telling us like the for loop is just, that's where it's getting the information. It's like, how do I know which city it is? Oh, give me the next one in that list. Give me the next one in that list, and so on and so on. Yeah, and so the reason why we can do this is because it's an iterable. Note that other iterables are things like tuples, lists are iterables. There's also other things called generators that are iterables that you can actually pull out the next element and stuff like that too. So there's a whole wide cast of things. You may or may not, who's seen range already? You might have seen this already referenced. Give me a thumbs up to see range. So range is actually a fun one because you'll notice that if I try range, it gives me 0 to 10. Like, what the heck's that, right? But if I do for I in range, and I, you'll see it gives me 0, 1, 2, all the way through 9. Range is actually a generator. It's a type of, it's built into function, into Python already. And basically, it's just saying, whenever you go through this for loop, if I try to like look at range by itself, like you saw if I just do range of 10, you can see it's like, oh, it doesn't really give me anything. If, for example, if I try to get like the first element in here, you can get that one. But what if I get like the third element? It gives me that one too. It's like, oh, it kind of looks like a list. And that's because it kind of is like a list, but it's just pulling out that next one. We're iterating over it. So this basically is just saying what's happening here is that for I in range of 10, it goes, okay, first time we're like for loop goes, all right, we're starting off. Give me the first one. Like, go ahead and give me the very first one. And range 10 goes, oh, the first one is 0. And it gives I 0 to I, does some stuff, and then it goes back to the top and says, all right, the for loop goes, give me the second one. right? And says, okay, the next one is this guy, and goes on and on like this. What's nice about this, now this is not super obvious, is that what's really nice about this is that it doesn't actually do it on the fly. So when we do like a list, like let's say, I'll make it really long, but like say 1, 2, 3, 4, 5, 6, 7, 8, and so on. This actually has to be stored in memory. So imagine your list is 1 billion items long, right? Super, super long. The problem is like 1 billion items long takes space on the computer's like storage, right? This memory, I'm kind of simplifying it, but it's keeping space on that computer. So the problem is that if you try to create a big list and you try doing a for loop on that list, the computer's like, oh, I have to store all of this and just pull out each one. If you already know it's gonna be like, oh, let's say, for example, if I try to do like for range of, gonna crash? No, that was fast, right? And we know that is a big, that's a lot of numbers in there, right? If I tried for looping over this, this would take all class, in fact, probably take the whole rest of the day, depending how fast this goes. So what's nice about this is that basically all this range 10, this generator says, hey, like, I'm not gonna do anything yet. It's like that student who's like, all right, like back in school, you've been the student, I'm sure, I've been the student. It's like, hey, I'm not gonna do my work unless the teacher's gonna check on it. But if the teacher comes check on it, I'm gonna do that quick homework really quickly and then show it to her. That's essentially what's going on here, is that range isn't gonna do anything until it's asked to give me the first element. So for example, if I ask for the first element, hey, that was really quick. What if you give me like the 5th element? Awesome. Now, now one thing you'll notice is executed time right here. This is gonna be kind of nice. If I do like 5,000, you see it takes a little bit extra time. Okay, and what's nice is that it's actually knowing what things to do ahead of time, so it's doing some extra stuff. But if I go ahead and try to do this right here and try to print each one, just watch kind of like how this kind of hangs a little bit. And you'll see it keeps going. You see this guy right here, and the computer's pretty decently fast. It's going by, but it's keep going, stuff like that. So you can see it takes a long time. It's actually pulling up everything as it goes through. But it's nice because we don't actually have to worry about doing that every time. So anyway.
It basically calculates the next value when you call it.
That's
so
right.
It's not calculating the whole list for you in one shot. Each time you call it, it calculates a new one. So it's not wasting a lot of time. It's just doing what you're asking it for that moment.
That's right. The only reason why it takes a long time is because of this guy right here. And there's also some optimizations, which is why I can give this one. It doesn't actually have to go through all, what's that, 500,000? Or 5 million or something like that. It doesn't have to go through all 5 million and then pull up that one. Range actually is smart enough in that generator says, hey, I don't need to calculate all this. I know what the 5 millionth one is, and it just passes that off to you. So that's the plus of generators. And we'll see this in data science a lot because we're going to use data frames and stuff like this that are really useful. You'll hear me use this word vectorize and things like that. Oh, mind if I, sorry. But yeah, so anyway, I just wanted to show a little bit of like for loops can be used within like not just a list, but can also be just anything that's an iterable. Okay. Cool. So I have a couple minutes. Tell you what, I don't have anything going on for the next like few minutes. You guys okay if I just kind of continue on for next few minutes to finish this up? All right, cool. All right, so that is some basic for loops right here. We can do some more complicated stuff. You can see like here, for city, I can get like only the first 5 cities here, right? And then I can say, okay, like I plus equals 1. So this is gonna count every time I comes through. And I can do the same thing, lower.cities append, print lower.cities. So this is going to show you, it's gonna add up every individual one. So note that this hasn't changed. I'm actually gonna get rid of this guy. Is that all I'm doing basically is just iterating over this top travel cities, which again is this guy. And we're only gonna go through the first 5 of them. Okay, and so this will actually go through the first 5 of those, and you'll see it print out each time. And you can see is that lower.cities is just being added up every time because I'm just printing out that part. And you can see going through. And in fact, if I go, let's say if I go ahead and print out a print I, you'll see I should be 5. Yeah, you can see 5 actually right here. And that's because it's been doing all these operations. So for loops allow you kind of extra control, like doing the same process over and over and over again. Note you can then combine things like if statements in here and stuff like that. You can get really complicated stuff. You can even do nested for loops. So for loops within for loops and stuff like this. So you can think of like for every loop that happens. So if I, for example, I did something like for I in range, I think you guys feel pretty comfortable with this. So this is gonna go through 0, 1, 2, 3, 4, all the way through 9. and then I can do for I, or let's say j in range of 5. So what's going to happen here, it's going to first pull out I from range of 10. So the very first one's going to be 0. It's going to print out 0. And then it's going to, for every number it pulls out for I, it's going to go ahead and do something for j. So in this case, I'll just go ahead and say print, let's say j. Oops, there we go. So this is going to say 0, and then it's going to go through 0, 1, 2, 3, 4, and then it'll stop, because that's all it goes through. It goes to the very beginning. Sorry, let me just make this clear. So if I go from here, this is going to go from the first one right here, go all the way through, ends here, pops back up, goes through all of it again, pops back up. But the thing is right here is that it's going to repeat this over and over and over again until it reaches the end of range 5, stops here, and then does this part, and then goes back up. So what we'll see here is if I run this, it'll be 0, and then it'll be 0, 1, 2, 3, 4, and then end, and then I'll go back up. It'll print 1, 0, 1, 2, 3, 4, and then end, and then so on and so forth. So you'll see this now. It's basically running 2 loops in there. So you can see here 0, which is this I, and then j, 0, 1, 2, 3, 4, end. And it's like, okay, it ends right here, goes up back up. I says, hey, range 10, give me another one. And range 10 gives them the number 1. And then it says, okay, print the number 1. And then for this part, it's going to do 0, 1, 2, 3, 4. Basically keeps looping, 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 and then prints end, and so on. So you can see here a little bit, it'll go all the way up to 9. Okay. Cool. Does that make sense to everyone? How's this kind of repeating through? Any questions at all about how this works? Okay, cool. So those are some nested loops. So note that this is really typical where if you have a nested loop and you're not careful, note that it doesn't run like 10, 15 times. This is running 10 times, 5 times. It's running 50 times all the way through. So if I counted the number of numbers in here, if I counted just these 0, 1, 2, 3, 4, this is repeated 10 different times. Okay, cool. All right. So let's hear while loops. I'm not going to go too much into while loops, but they're a useful thing. While loops basically are a little bit different. Like in most languages, you'd say, oh, while loops and for loops are pretty similar. While loops in Python are a little bit different from for loops, but the main thing is basically saying, okay, while this condition is true, do all of these things underneath here. Okay, so note that you can get in something called an infinite loop. Basically, if this condition is never like not met, this will keep going on and on and on and on forever. So what's a simple condition that I could put into this while loop that would make it go on forever? Anyone? Oh.
While one.
True. 1, true, anything.
I heard true, I heard while 1, right?
Yeah.
So yeah, so if I do like something like this is going to evaluate true every single time, and it's just going to go for it, right? And you can see here, it's just going to keep going and going and going, never stop. Which like, oops, infinite loop. This of course eventually will stop depending on how the computer's set up. But the point is that this would not be ideal. So if I do stop number is greater than or equal to 0, now I have stop number equals 4. I have print the stop number, which is why we see all these numbers. Oops. Sorry. It'll print out each of these numbers. And then I have stop number minus equal 1. So this will make the stop number smaller and smaller. Okay. So yeah, so you have any questions or comments? No? Okay, so if I run this now, this should go 4, 3, 2, 1. And then since it's not greater than 0, at this very last part, it checks it and says, oh, I'm no longer greater than 0, so it stops. There it goes. Okay. Cool. Any questions? Any comments? No? All right. I'm gonna mute you for a second. Okay, cool. So next part is a little mentioned in the curriculum, continue and break statements. I will say is that there are some debates in computer science about whether you should have break statements or not. Typically I personally tend to avoid them because it makes less sense, but sometimes it makes sense for what you're trying to do. So break statements will basically have a certain time, like if you're in a for loop or in a while loop, it will break out of that loop and it will stop right there. So it's as if the condition was met or the for loop finished iterating through everything. So this is usually paired up with like if statements. So for example, right here, if I didn't have this guy, let's say if I just have this guy right here, this is going to keep going until we reach into 11. So you can see if I print this out, it goes all the way there. But if I have this if I equals 5, so that means when I equals 5 exactly, it's going to print break free and then break, and it won't do anything anymore. So if I run this now, you'll see it stops at 5, break free. Okay. So this can be really useful if you want it to like stop certain execution. Note, however, if I did something like this, this won't ever get passed because it never set equal to 5. So you can see here it just kept going until it reached 10. Okay, cool. Makes sense to everyone for this break? Okay, cool. All right, continue is kind of the similar idea, but continue is instead of like breaking, it'll stop that at that point and just go back to the beginning. So instead of going like here, like if I had this guy right here, and I have this run, you can see it says after continue, after continue, after continue, it does it all 10 times. But if I have this here, this is going to say, oh, you know, is it modulo 2? Basically, is this an even number, right? And basically, it will continue if it's reached that part and go back to the beginning. So I'll never actually write this part here. So you'll see in this case, what will happen is only half of the print statements will be here. So instead of after the continue, you'll see it be like 1, 3, 5, 7, 9. Because basically, if it gets to like 2, it says 2 modulo 2 is equal to 0. I'll continue, it goes back to the beginning here, and then keeps going. Okay.